Okay, section 3.5. Let me go over my notes real quickly, and then I'll work three problems. I'll try to keep this short. I just basically summed up what the textbook says at the beginning. They're introducing us to functions, and they do so by relating them to hourly wage, assuming that most of us understand work. So Billy Bob makes 7.50 an hour, and the stipulation is no chance of overtime. By doing so, we know that he can't work negative hours, but he can work anywhere from no hours to 40 hours. Now, if he could work overtime, we'd need a different function. But for anything up through 40, well, unless they let him work overtime with no extra pay, and then Billy Bob's just an idiot. So y equals 7.5x. Makes sense. X is our hours. We plug in how many hours we work, and we find our total pay, which is y. So y equals our hourly wage times how many hours. So in this case, x falls between 0 and 40. Now, if we plug 0 in for x, we'll find our low end for y, what we would make if we didn't work at all, 0. And then we plug 40 hours in, and we find out our actual, we'll get to that later, we'll get to our actual pay for the week. So example 1 says create a table and graph, and then I mentioned our input values are x. Those are the numbers we put in. We have to have hours to know how much we're going to make. So what we know is how many hours we work or how many hours we plan to work. Plug that in, that's our input, that gives us our output. So x they'll call input, y they'll call output. You don't necessarily have to remember that much unless you take college algebra and start messing with the calculators more. Then it's going to matter more with the terminology. Our terminology we're concerned with domain and range, and it's simple. Domain is literally all x values, all input, but just remember domain is x, range is y. So domain is x, range is y. Function, in order to be a function, it's not super clear, I apologize. In order to be a function, we can't have repeating x values. So a set of ordered pairs in which no two different ordered pairs have the same first coordinate. It's a fancy way of saying x does not repeat. So domain is our x's, range is our y's. If an x repeats, it is not a function. Then here, state the domain and range, and they take us back to our hourly page, or hourly pay. Our domain is literally our x values, anything from 0 to 40. So domain, we would write our little whirly-giggers here to do it correctly, and this is just taking the place of words. When you see this in the book, it means x such that x is between 0 and 40. This is all x. That's what this means. The x before that slash, before the vertical line, means all x values. And then this shows where they lie. So there's our domain. Then to find our range, like I mentioned earlier, we plug in our lowest x value. That's the bottom of our domain. We plug that in, and it gives us 0. 7.5 times 0 is 0. So our range goes from 0, because I can get a y value of 0 with the lowest x value. I can't go lower than that because I'm not working negative. And then the most hours we can work in this case is 40, no chance of overtime. So we plug our top end of our domain in, which is 40. The outcome, our y value is 300. So that means we can make anywhere from 0 to $300 basically in a week at $7.50 an hour. So our range is all y values such that y is more than 0, less than 300, or equal to. And then a relationship is not a function if x repeats. I already mentioned that. Here's a case of a table. So it said sketch the graph of y, x equals y squared. You just start plugging numbers in, and pretty soon you'll see that when you plug a number in for anything squared, you notice that the negative value of that plugged in is going to give you the same answer. I can't say output because they switched the y's and the x's here. But if my y is 1, 1 squared is 1, my x would be 1. But if my y is -1, -1 times -1 is 1, it gives me the same x. So what happens is I have repeating x values, and I'll have a repeat for every single negative value of the positive. So it's not a function. Now, the other way to check if it's a function or not, if they just give you a graph, do the vertical line test. That's all you have to do. Vertical line test means just draw a vertical line. If that vertical line crosses the graph twice, it means you have the same x value. So you can see it here. It crosses the 1, it crosses 2, it crosses 3, it crosses every one of them twice because that y is squared. So x is 1, x is 1, x is 4, x is 4, not a function. It only takes one repeat to make it not a function. And then they're matching each relation to its graph. You see an absolute value, you know it's going to be a spike, it's going to be straight lines. You see x squared, you know you're dealing with a parabola. So it's going to, doesn't even matter up or down if they only give you one, you know it's a parabola. And then here's just a line. So there's tricks to kind of know what graph is going to be what. You know anything squared is going to give you an ellipse. Well, it could be, if it's y or x, it could give you an ellipse or a parabola. We had an ellipse there. But either way, squared means you've got a u of some sort. Absolute value means you've got a spike of some sort. Straight line going both ways. And then y equals some x plus something is always a straight line. Okay. So let me get into some examples here. I thought yellow paper would look kind of cool. I think it sucks, I guess. So I'll switch back to white after this. Number 1, just to give you some helpful information before you attack these. I tried to take one from each category, basically. Number 1 just gives you a list of coordinate points, data points, and tells you to list the domain and range. That's the one I started, and then my 3-year-old came in. So here's a clean one. So it gave us these points. Our domain is literally x values. We have a 1, a 3, a 5, a 7. What we do is write each one of them down. X is 1, x is 3, x is 5, x is 7. You don't repeat values. If there's 2 of them, don't write them twice, just write it once. If there's 2 3s, it just means x can be 3 twice for the coordinate point. Just write each x value once when you're stating what the domain is. And then the range, because domain and range is talking what x values and what y values. Now my y, I just go to the opposite. And I say, okay, there's my y values. I have a 2, I have a 4, I have a 6, and I have an 8. Done. That's domain and range. So don't let the terminology throw you off. Don't let it confuse you. Don't overanalyze. They ask for domain, write the x values you see, the different x values. If they ask for range, write the y values. Now 13, number 9 through 18, so 9 through 17 on your homework, they just give you graphs. Well, when you get those, then use the vertical line test. If you draw a vertical line, when you draw a vertical line, if it crosses the graph twice, and you know it's a vertical line, you stayed on the same x value. Let's say this was x equals 3 all the way down. If it crosses twice, not a function. You can have some crazy wacky looking thing, frequency of some sort, and it can be a function as long as you don't have the same x value. So vertical line test is all you're doing for 9 through 17. Now 23, it gets a little more complicated. Graph, find domain and range, indicate if it's a function. I still like doing this in class. I like showing a table, and here's my x, here's my y. Obviously, I'll start with 0 to see what happens. When I zero it out for x, I know that my y is -1. Well, when you have a squared, some of you already are thinking this way, some of you will learn this concept. When you have a square, you start thinking, okay, I can plug anything in for a squared, any number, doesn't matter what I plug in. So I like to start with a -1, easy, whatever. If I plug in a -1, I know that -1 times -1 is a +1. 1 minus 1 is 0. If I plug in a -2, well, now I have a -2 times a -2 is +4. 4 minus 1 is 3. And I'll do one more. Just, it depends on, if you understand it, you don't have to go any further. If I plug a -3 in, again, negative is a positive and it's getting bigger. I'm getting bigger values. So I'm not going smaller even using negative numbers. So -3 is 9, -1 is 8. So now I go the opposite way. It's okay, what if I use a positive and I throw 1 in? Well, 1 minus 1 is 0. Again, I come up with 0. If I throw in a +2, well, now I get 2 times 2 is 4, and 4 minus 1 is 3. If I throw in a +3, I get 9, minus 1 is 8. You see what happens. You see what happens when you have a squared value. You're going to have matching points on one or the other, depending on which one's squared. In this case, my x is squared. So it doesn't matter what I plug in, the negative will equal the same y value as a positive because it's squared, so the negatives become positive. So I know that my domain is all real numbers, and my range, I just look at this and I can see what happens. I have 2 zeros, then I go up to 3, and then I go up to 8. I'm getting bigger after 0. The lowest I can go, the only way I get a negative is a 0 x value. Every other x value gives me 0 or a positive value. So the only negative is -1. That means, and I'll just write it like this first, y is greater than or equal to -1. If you want to write it, and I think they do for 23, yeah, they want us to write it out technically. So our range is all y's such that y is greater than or equal to -1. So that's all they wanted. They wrote it backward. I should have written it different. They wrote it. I wrote the -1. It doesn't really matter how you do this, greater than. That's how the book wants it. Same idea, same thing. So all y such that y is greater than or equal to -1. That's section 3.5. Not too bad, and there's not a ton of problems to work in this one that I assigned. All right, so I'll get to 3.6 in a little bit here. Hopefully this makes sense to you. Good luck with it.